We want to look at adding and subtracting fractions next. So let's start with this. So 5/8 plus 2/8 is equal to 7/8. We're in the easy case here where the denominators are the same, so we have 8 on the bottom. So then you're just counting how many 8s do you have. Well, there's 5 over here, 2 over here, so 5/8 plus 2/8 is equal to 7/8, so 7 over 8. Just like, yeah, so 5 of anything, 5 apples plus 2 apples equals 7 apples. Instead of apples here, we have 8s. Yeah, when I say 8s, I mean these guys. And here's the picture version. So here's 5/8. So a rectangle divided into 8 equal pieces. Shade in 5 of them, that's 5/8. Here we have 2/8. So what's the total? So if you put these shaded areas together, you get 7/8. And subtraction similar. So again, if you have the same denominator, then you can just subtract the top. So 5/8 minus 2/8 is 3/8. So if you take these 2/8 away from the 5, you're left with 3. So yeah, so there's a simple rule. A over C plus B over C is equal to A plus B over C. And the same for subtraction. Example 1, yeah, here we have tenths. 3/10 plus 1/10. Okay, so here's C is 10. So we get 4/10. And yeah, so this is an answer, but yeah, we're always expected to simplify any fractions we get. Okay, so reduce this. There's a common factor 2. This is 2 times 2. This is 2 times 5. So if you cancel 2's or divide the top by 2, divide the bottom by 2, so 2 is the greatest common factor. The best answer is 2/5. Yeah, we always want our answers in lowest terms, so use the smallest numbers possible. Okay, so in the book, yeah, it's the same formulas. Yeah, we're just getting used to these types of examples. 1/5 plus 2/5 is 3/5. 13/7 minus 2/7. Well, 13 minus 2 is 11, so that's 11/7. This is an improper fraction, so yeah, you could leave it as 11/7, but sometimes it's useful to convert improper fractions to mixed numbers. So 7 goes into 11 one time, that's the whole number piece. Remainder 4, so it's 1 and 4/7. Here's another example with eighths. And 2/8 reduces to 1/4. Okay, yeah, and if an example like this, 11 fifteenths plus 13 fifteenths plus 8 fifteenths, it's the same deal. You're just adding the tops together. 11 plus 13 is 24, plus 8 is 32. So you get 32 fifteenths. All right, so the next case, oh yeah, just to mention, a common mistake is to also add the bottoms. So that's not correct. So you can see here it's the bottoms stay the same. So if you're adding eighths, the answer is eighths. Okay, so this is not correct. Yeah, it should be 4/10ths, not 4/20ths. Some jargon here. Fractions with the same denominator are called like fractions. Fractions with different denominators are called unlike fractions. So the more difficult case has unlike fractions. Example 2, find 5/8 plus 1/4. So these two bottom numbers, these two denominators are different. So these are, we're adding unlike fractions here. And now the bad news is, yeah, there's no way to add these directly. We need a common denominator, so we really the only way to add two fractions is if the denominator is the same. Okay, we have different denominators, so how can we fix that? Well, if you remember, we've seen there is a way to, we can write fractions differently. If you have a fraction a over b, that's equal to a times c over b times c for any number c. Okay, so there are lots of equivalent fractions. Right, so the idea here is I want the same denominators, so I'm going to hit the top and bottom with 2's. Okay, that gives me what I want on the bottom. 4 times 2 is 8. But the top also changes, so 1 times 2 is 2. Okay, so there's a middle step we need here. So to add 5/8 plus 1/4, I have to get a common denominator, so but it's easy to do here, so 1/4 is equal to 2/8. So now we can add them. It's 7/8. Yeah, so this is the same as we saw earlier. All right, so the moral of the story is, yeah, whenever you're adding fractions, you need a common denominator. In the easy case, the denominators are already the same, but if you have unlike fractions, then you need to, as an extra step. Okay, and you remember this rule from last time, or the time before? Yeah, we're using this in two directions. So if you're starting on the right side, then you can cancel c's and get just a over b. But sometimes, like here, we need to make the fraction more complicated. So here we're introducing 2's. But as long as you're multiplying top and bottom by the same number, then it's everything's equal. So you haven't changed the problem. Yeah, I guess it's easy to forget. I mean, if I just multiply 2 on the bottom, then I'm changing the question. So you have to multiply by the top and the bottom to keep it the same. So you want an equivalent fraction. All right, so don't forget to multiply on the top as well. Oh yeah, and don't do this. So yeah, I see this so often. So 5/8 plus 1/4. Yeah, well, we're used to adding the tops together. How about add the bottoms together? No, so this is not the right answer. You can do this, but I won't give you any points. So put a big cross through that. All right, so yeah, if you forget how to add fractions, add the tops, add the bottoms, but that's not correct. You have to do it like this. So our golden rule, if you're adding or subtracting fractions, you need a common denominator. It's the only way to do it. Okay, and we keep using this idea. Okay, so how about 1/2 plus 1/3? Yeah, here it is again. Okay, we need a common denominator, so the question we're asking, so what should we multiply on the top and the bottom to get the same number on the bottom? Okay, well, here we can see as 6, we can get 6 as a common denominator. So if you multiply the top and bottom by 3 here, you get 3/6. Okay, so 1/2 is equivalent to 3/6. How about 1/3? Should I multiply top and bottom by 3? No, so yep, I want to get the same denominator, so multiply top and bottom by 2. All right, so it's really, what do you have to multiply 2 by to get 6? What do you have to multiply 3 by to get 6? And then just whatever you're multiplying by, make sure you do it on the top and the bottom. And so here's the same question with a common denominator 6. And now we're back to like fractions. 3 plus 2 is 5, so the answer is 5/6. Yeah, so maybe it's helpful to see, yeah, I like these rectangles. So here's 1/2, here's 1/3. Again, yeah, so if you put this shaded piece in here, you're getting 1/2 plus 1/3, but to really recognize what that fraction is, we need sixths. So divide this into this half into 3 pieces, this half into 3 pieces, each of these into 2. Okay, so now we can see what we're doing. Yeah, it's just we're really adding 3/6 plus 2/6, so 5/6. All right, so yeah, that's a nice way to think of it. And it's exactly the same for subtraction. So 3/7 minus 2/5. Yeah, we're In the difficult case, we have unlike fractions, different denominators. Okay, so you can see that a common denominator we can use is 35. So if we hit this first guy with 5s, multiply the top and bottom by 5, we get 15 35ths. And for the second guy, yeah, we want 35 on the bottom, so multiply by 7 and do the same on the top. Okay, so 2/5 is equivalent to 14 35ths. And again, now subtract the like fractions. 15 minus 14 is 1. So 1 35th. So maybe the tricky part here is, so where did that 35 come from? Yeah, I mean, if you're adding or subtracting two fractions, you can always take the product of the denominators to be a common denominator. But sometimes you can do better than that. Example 5, find 3/10 plus 1/4. Okay, so first solution, use the common denominator of 40, so just taking the product. So 3/10, that's the same as 12/40, plus 1/4, that's the same as 10/40. Okay, so taking C to be 4 here, taking C to be 10. So how many 40ths? That's 12 plus 10, that's 22 40ths. And yeah, these are two even numbers, so they certainly have a 2 in common. 2 is the greatest common factor. So if you cancel 2 out of the top and the bottom, you get 11 20ths. So that's the best answer. That's the simplified answer. Okay, so that worked. Was there an easier way to do this question? Maybe with smaller numbers and not needing this last step? Yeah, so there is a second solution. So in fact, we can use a common denominator of 20. Okay, so that 3/10, if you multiply top and bottom by 2, you get 6/20. And for that 1/4, if you multiply top and bottom by 5, you get 5/20. And now adding these, that's 11/20. Okay, so that was quicker. Yeah, we always want to use numbers that are as small as possible. So yeah, 20 is smaller than 40. And also, yeah, we didn't need to do any cancellation, so that last, we didn't need to do a simplifying step here. Okay, so this first one we used a common denominator of 40. For the second solution, we used a common denominator of 20. So what's the smallest possible common denominator we can use? Can we do better than 20? yeah, I mean, we're using this idea. So the equivalent fractions we're looking for, their denominators are always going to be multiples of the original. Okay, so one way to think about this question, if you look at all the multiples of 10 and all the multiples of 4, what's the smallest common multiple? And that'll be the smallest number we can use. Okay, so the multiples of 10, so 1 times 10, 2 times 10, 3 times 4 times, that should be a 50. The multiples of 4, 4, 8, 12, 16, 20, 24. And yeah, so the smallest common multiple is 20. And it's 5. But this is the smallest number in both lists. Yeah, you can see 40 is a possible common denominator, but 20 is the smallest. So in the jargon, so 20 is the least common multiple, LCM, of 10 and 4. And that means 20 is the least common denominator of these two fractions. So the LCD. All right, so we've got lots of acronyms. Remember we had GCF, the greatest common factor, but this is a different idea. Okay, more examples. Example 6, find 1/10 plus 3/4 minus 7/20. Okay, so we can see from our work already that if we're looking for the least common multiple of 10, 4, and 20, it has to be 20. So that's the LCD for this question. Okay, so the idea is we're going to rewrite these fractions as some number over 20. Well, what do you have to multiply 10 by to get 20? 2. Okay, so use 2's here. 4 times 5 is 20, so use 5's here. And we already have 20. You can multiply it by 1's if you want, but it's this just stays the same. Now we have like fractions, so everything's over 20. 2/20 plus 15/20 minus 7/20. So that's 2 plus 15, 17, minus 7 is 10. So 10 over 20, and yeah, don't leave it like that. That simplifies to 1/2. All right, so looking for least common denominators is really the same thing as looking for the least common multiples of the denominators of your fraction. And so let's study this idea a little. Okay, it's a good name. It describes what it is. So for any number m, its multiples just multiply by 1, 2, 3, 4. You get an infinite list. So the multiples of 6, so 1 times 6, 2 times 6 is 12, 3 times 6, 18, 4 times 6, 5 times 6. But if you're making this list, maybe it's easier just to add another 6 each time. So 24 plus 6, that's 30. Next one, 36, 42. Multiples of 8. So 1 times 8, 2 times 8, or add another 8 each time. Okay, so we already have enough numbers to see that the least common multiple of 6 and 8, so the smallest number in both of these lists is, this 24. We have 8 and 16 here, but there are no 8s or 16s in the top. But 24 matches. I mean, there will be other common multiples. 48 will be a common multiple. But if you want the least, the smallest common multiple, that's 24. The least common multiple, don't confuse this with our earlier idea, greatest common factor. So if you look at all the factors of 6 and all the factors of 8, the greatest common factor is 2. All right, so one way to remember it, the greatest common factor, it's always smaller than the two numbers. The least common multiple is always going to be bigger than the two numbers. Example 7, find the least common multiple of these three numbers. Okay, so if the numbers are small, you can definitely do it this way. Just make a list. All the multiples. We saw 6 already. 9, multiples of 9. Multiples of 12. And then maybe start with the biggest numbers multiples and look to see if it appears in the other two, or in the other lists. So 12 is a multiple of 6, but not a multiple of 9. So 12 is no good. 24, I see that here, but not here. 36, so 36. That's the first number that's in all three. So 36 is the least common multiple of 6, 9, and 12. And actually for this example, we can kind of ignore 6 because 12 is a multiple of 6. So if you're a multiple of 12, you're automatically a multiple of 6. Okay, now there wasn't another way to do this question using the prime factorizations. Okay, so you remember this idea. So any number, you can break it down into its prime factors. You remember those factor trees. This is easy. So 6 is 2 times 3. 9 is 3 times 3. And 12, you could break it as 4 times 3, and then 4 is 2 times 2. So 12 is 2 times 2 times 3. Okay, so why is this helpful if you're looking for least common multiples? Well, you can kind of look at each prime here. So to be a multiple of all three numbers, you need enough factors. Okay, so if you're looking for a, um, a multiple of 6, 9, and 12, well, in terms of twos, it has to contain not just one 2, it has to contain two 2s, so 2 times 2. All right, so we need at least a couple of 2s multiplied together. In terms of threes, well, to be a multiple of 6, 9, and 12, we need at least 2 3s multiplied together in order for 9 to be a multiple of 9. Okay, and so once you have 2 2s and 2 3s, that covers everything. So the least common multiple is 2 times 2 times 3 times 3. That's 36 again. Okay, so you're just looking, what's the smallest number of factors you need that covers all three of these numbers. Well, if you have 2 2s and 2 3s, then you're going to be a multiple of these three, and that'll be the smallest common multiple. You could have six 2s and 7 3s. That'll be a common multiple, but it won't be the smallest. So that the smallest you can get away with is 2 times 2 times 3 times 3. This 6 only has 1 2, so could we get away with just using 1 2 here? No, so to be a multiple of 12, you need 2 times 2. All right, so yes, really we're picking the highest power. We have a 2 squared here, we have a 3 squared, so we need those primes squared. Another example of that, to find the least common multiple of 21 and 35. Okay, so you could make lists, list all the multiples. But if you understand it, yeah, this is certainly easier. Just use the prime factorizations. 21 is 3 times 7. 35 is 5 times 7. Okay, so we see primes 3, 5, and 7. Okay, so to be a common multiple, we need at least 1 3. We need 1 5. And if we have 1 7, then we've covered each of these. So the least common multiple is just 3 times 5 times 7. Yeah, that's 15 times 7, 105. Okay, so we don't need 2 7s because just 1 7 is enough to cover this and this. Okay, you can see, yeah, 21 is a factor of this guy, 3 times 7. And 35 is also in here, 5 times 7. Okay, so this is a common multiple of these two, and it's the least common multiple. All right, in the book, I think, yeah, there's more examples. Yeah, so here's the LCM. Yeah, so here's a more difficult one. Find the least common multiple of these two numbers. And yeah, here we're given the prime factorizations. So looking at each prime, so I'm looking at the twos, yes, so we have there's 1, 2 here, but there are 4 twos here, so to be a common multiple, we'll need 4 twos, so 2 to the power 4. Here we have 2 threes, 3 times 3. Here we have 3 to the power 4. So again, we'll take the highest power. We need to cover all those threes. We'll need 1, 7, and we'll need 1, 11. All right, so the LCM of these two numbers, it's the product of all these. Okay, and again, yeah, we're choosing the highest power of each prime that appears. Okay, yeah, and you can see A is a factor of this guy. B is in here. B is a factor, and this is the best you can do, the smallest common multiple. Okay, and why do we care about least common multiples? Well, yeah, that's the best number you can use as the common denominator. Okay, so example 9, find the least common denominator for these two fractions, 1 over 44 and 32 over 33, and use this least common denominator to add those two fractions. So 44 breaks up as 4 times 11. 11's prime, but 4 is 2 times 2. So prime factorization of 44 is 2 times 2 times 11. 33, yeah, that's just 3 times 11. So that's its prime factorization. And so the least common multiple of these two numbers, well, I need 2 2's to cover this. I need a 3, and I need 1 11. That'll cover both of these. And so the least common multiple is 2 times 2 times 3 times 11. Yeah, that's 4 times 3, 12 times 11, 132. So 132 is the least common multiple of the two denominators. So that's the least common denominator. All right, so yeah, this is a kind of bigger number. So the idea is now we want to rewrite these two are two fractions. Yeah, so to do this addition, we want to replace 44 and 33 by this guy, this least common denominator. So the question is, yeah, so what do you have to multiply 44 by to get 132? So in other words, how many times does 44 fit into 132? In other words, what's 132 divided by 44? Well, 44 goes into 132 3 times. Okay, so you could find this 3. So this is the 3 we need. We need a 3 here. You could find this 3 by division. But the easiest way to find it is just compare the prime factors of 44 with the prime factors of 132, and you can see what's missing. So there's a 3 missing here. So if you multiply 44 by 3, you get 132. Same thing here. So what do you have to multiply 33 by to get 132? Well, here's 33, so multiply 33 by 4, you get 132. Okay, so we need 4s here. So this is 3 over 132. This is, 32 times 4 is 128. So this is 128 over 132. And now we can see what we're doing. So so it's on top. We have like fractions now, so it's 3 plus 128. That's 131 over 132. Okay, yeah, so for bigger numbers, it's certainly more work. And for these bigger numbers, I certainly recommend, you could make lists of multiples and find the least common multiple, but I definitely recommend use the prime factorizations. They help you see what's going on, so you can get the LCD, and you can also see what numbers you should be multiplying to get that LCD. And again, if you're multiplying by 4 on the bottom, don't forget to multiply by 4 on the top to keep it equal. If you forget to multiply by the 4 on the top, then they're not equal, and you'll get the wrong answer. Okay, in the book, so here's a nasty looking example. So we have unlike fractions here. So they already worked out the LCM of 8, 10, and 18 is 360. So you need the 8 needs 3 2s, the 10 needs a 5, and the 18 needs 3 2s. So that's 360. So the LCD is 360. And then you can see what you need. So 8 times 45. So you need 45s here. 10 times 36. 36 is here. And 20s here. So it's a lot of work, this question, if you have bigger numbers. And just a final step. We have this answer, but can we simplify it? Well, the only factors of 360 are 2s, 3s, and 5s. And if you divide 173 by 2s, 3s, and 5s, you don't get a 0 remainder. So this is, it's already reduced. Okay, one more here. 14 over 25 minus 2 over 10. Okay, so can we see that the least common denominator is 50? Yeah, I mean, that's, so yeah, this, you can use the lists here. So the multiples of 25 are 25, 50, 75, and yeah, 50 is the first multiple of 10. Okay, so we're going to put 50s on the bottom. Yeah, we just need multiply the first guy by 2's, so that's 28 over 50. What do we need here for this 2/10? Well, 10 times 5 is 50, so we need 5's here. So 2 over 10 is equivalent to 10 over 50. So this is our subtraction with like fractions. So that's 18 over 50. Okay, so we use the least common denominator, but yeah, it's still, that doesn't mean that we don't sometimes need to simplify the answer. And yeah, there is a common factor 2 here. So 18 divided by 2 is 9. 50 divided by 2 is 25. Yeah, so now it's reduced. Just 5's in the bottom, 3's in the top. Yeah, so this is the best answer, 9/25. It's, yeah, I guess. Yeah, I guess there was an easier way to do this question. Yeah, this 2/10 is really 1/5. So that might have been a better first step here. So if you simplify 2/10 to 1/5, then you get an easier question. Then the LCD is just 25, and less simplifying at the end. All right, so that's I think we've covered that section.